The clouds over the planet Neptune have suddenly vanished. Clouds on Neptune have almost disappeared, a rare event in the past 30 years of observations. Pictures taken from 1994 to 2022, both from Mauna Kea and Hawaii Island through the W.M. Keck Observatory and NASA's Hubble Space Telescope, show that only the South Pole retains some clouds. Neptune observed with NIRC2 on the Keck telescope at 163 mm from 2002 through June 2023. The findings shared on the Icarus Journal also suggest a surprising link between Neptune's vanishing clouds and its solar cycle. Despite being the farthest planet, the major planet from our sun, and getting only a tiny fraction of Earth's sunlight, 1/900th, you could imagine, the changes in the solar cycle seem to impact Neptune's clouds anyway. Scientists from University of California, UC Berkeley, noticed that the unusual collection of clouds around Neptune's middle area began to diminish in 2019. I was surprised by how quickly clouds disappeared on Neptune, said Imke de Pater, senior author of the study and emeritus professor of astronomy at UC Berkeley. He said, "We essentially saw cloud activity drop within a few months. Even 4 years later, the images we took this past June showed the clouds have not returned to their former levels," said Erandi Chavez, graduate student at Harvard University Center for Astrophysics, who headed the research as an undergrad astronomy student at UC Berkeley. He said, "This is extremely exciting and unexpected, especially since Neptune's previous period of low cloud activity was not nearly as dramatic and prolonged." To track these changes, Chavez and her team studied images from 1994 to 2022 using Keck Observatory's second-generation near-infrared camera, NIRC2, and its adaptive optic systems. They also used data from Lick Observatory 2018-2019 and Hubble Space Telescope since 1994. Recently, additional insights came from Keck Observatory's Twilight Observing Program and the Hubble Space Telescope Outer Planet Atmosphere's Legacy Opal program for short. The data uncovered an interesting connection between Neptune's cloud cover and the solar cycle. This cycle involves the sun's magnetic field flipping every 11 years, altering levels of solar radiation. More clouds tend to form on Neptune about 2 years after the sun emits strong ultraviolet UV light, especially the intense hydrogen Lima alpha emission. Moreover, the number of clouds corresponds to how bright the ice giant appears due to sunlight reflection. These remarkable data gave us the strongest evidence yet that Neptune's cloud cover correlates with the sun cycle, said de Pater. Our findings support that the theory that the sun's UV rays, when strong enough, may be triggering a photochemical reaction that produces Neptune's clouds. This connection between Neptune's cloud pattern and the solar cycle is found by looking at 2.5 cycles of cloud activity during the 29 years of watching Neptune. Over this time, Neptune got brighter in 2002, maximum brightness, dimmer in 2007, minimum brightness, brighter again in 2015, and darkest in 2020, when most clouds vanished. The changes in Neptune's brightness due to the sun seem to match the coming and going of clouds on the planet. But understanding this link needs more research because other things are involved. For example, while more UV sunlight might make more clouds and haze, it could also darken them, making Neptune less bright. Storms from deep within Neptune affect cloud cover, but these aren't tied to chemically made clouds, which makes linking them to the solar cycle complex. We need to keep watching Neptune to see how long the current cloud absence will last. This discovery adds to what we know about Neptune's active and wild atmosphere, full of methane clouds whipping by super-fast winds, the quickest anywhere in our solar system. One of the earliest and most famous pictures was taken by NASA's Voyager 2 in 1989, showing a huge storm called the Great Dark Spot. Other storms and dark spots have been seen since, including a big equatorial storm in 2017 and a large dark spot in the north in 2018. It's fascinating to be able to use telescopes on Earth to study the climate of a world more than 2.5 billion miles away from us, remarks Carlos Alvarez, a Keck Observatory staff astronomer and researcher co-author. Advances in technology as well as our twilight observing program have enabled us to constrain Neptune's atmospheric models, which are key to understanding the correlation between the ice giant's climate and the solar system. The team of researchers still keeping an eye on Neptune's clouds. They took new pictures in June 2023, which matched the time when NASA's James Webb Space Telescope also took pictures using near and mid-infrared light. The other planets may eventually collide with one another or be ejected out of the solar system if a star passing through our system changed Neptune's orbit by just 0.1%. This essentially means that the Earth and the entire solar system can collapse if this happens to Neptune. We've seen more clouds in the most recent images, in particular at northern latitudes and at high altitudes, as expected from the observed increase in the solar UV flux over the past 2 years, said De Peter. When they put together the information from James Webb Telescope and Keck Observatory, they can study more about how Neptune looks and what causes changes. This might also give astronomers better insights, not just about Neptune, but also about planets beyond our solar system. This is on Great Game India. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.